Alright guys, here's the next video. So in this one I'm going to show you how to render Zenith tyFlow VDBs in Arnold. So in the previous video I showed you exporting to VDB and rendering with VRay, and in that video I did not mention how to use the RGB if you wanted to use a different colors simulated in the solver. So just want to quickly show you that you can change this from here. So if the VDB has an RGB channel, that's the way to show it. And then I'm gonna delete this, and for the Arnold setup I'm gonna use two spheres which are gonna mix their colors. Standard primitives, tyFlow right here, open editor, and I'm gonna start with the Birth Inferno. Just gonna set up a very quick simulation, gonna add another emitter and pick this bow in this emitter and the other sphere in the other one. Come on. Alright. Both are burning. Just gonna direct them now towards one another. Enable color. Make it. Let me just scroll the timeline a bit so that I can change the color without recalculating the entire timeline. Here it is, and I'm gonna point this. I'm gonna turn off motion velocity. I'm gonna use vector velocity, so I'm gonna point it in the minus y direction. Z is 0. Alright, and I'm gonna do the opposite for the other emitter. I'm gonna enable color, use like this magenta, turn off motion, enable vector, and set it to positive y. Z is 0, and now eventually they're gonna collide. Yeah, they're not pointing straight at one another. Let me just turn down the vorticity because they're maybe a bit too curly. Right, here it is. Also, yeah, maybe I'm gonna also use PCG. They're not pointing straight towards one another, so they are gonna mismatch a little. Also, one of them is smaller than the other, but also gonna increase this to 0.4. Now this emitter is gonna prevail, and then I'm gonna use 0.4 here as well in order to equalize it. Now since this one is smaller, let me just equalize their sizes. 0.33, 0.33 for this one as well. Yeah, something like that. So the colors start mixing, we have some temperature, and that's ready to export. Let me add the export operator right here, export Inferno. Gonna save it as always to the desktop, and then I'm gonna create an old desktop 7 folder when it gets too full. So generate VDB files, generate. Right, and here they are. Yeah, also this part is a bit more purple, this one is a bit more green because they are not exactly aligned. Anyway, so that's interesting enough. It's gonna do the job. So gonna create an not a limbic, Arnold volume like this, and from here I will pick the VDB file, desktop, solver. This looks like an animated volume. What is animation? Yes. And now I can pick the channels that I want to use for different purposes. So the parameter grids are going to be the color density, temperature, not the velocity. And the velocity grids are going to be everything. It's going to be only the velocity, and everything else I'm going to uncheck. Set up a default standard volume shader, yes. Alright, and now something has imported. And we can see that we have a bounding box that shrinks and enlarges. So I'm gonna switch it. I can view it as wireframe, I gotta click those channels here, otherwise it's just the viewport is gonna go blank. So I gotta click any of those, and the cover cannot be previewed, so it stays disabled. So that's one thing that you have to watch out for. Active voxels or volume. All right, so I'm gonna display it as a volume, and you can see that it's using the wrong up axis, so I can change it from here, Z. So in order to match the position, again, as with the VRayVolumeGrid, you have to just set it to 0, 0, 0, and now it's gonna match. So now again in the viewport we're getting both shaders rendering on top of one another, and weird things are gonna happen. So I'm gonna move this to the side right now, so just in order to make stuff easier to do, but otherwise, yeah, in order for the positions to match, you have to set it to 0, 0. There are different display options here. I think that there are other tutorials explaining this, so not gonna go into much detail. That's just how you view stuff in the viewport. It's not important for the rendering. So the volume shader is right here. I'm gonna open the material editor, drag it, and that's the standard volume shader of Arnold. Gonna open the Arnold render view. Can only be used with the Arnold. You're currently in VRay 6. Oh yeah, please switch it to Arnold for this test. Yeah, and something renders. Now that happens because the stuff is not yet mapped. So I think that right here it picks just the first channel from the list. So it managed to identify that there are color, density, and temperature grids inside of the VDB. So it just slapped the first available channel here. But the color channel is not the thing that you want to use for opacity. There are colors in the entire VDB volume. So in all of the voxels, there is some color. So now it's gonna just show you the blocks. So I'm gonna use density. Ooh, am I typing on a timeline? Density. Right, how is this gonna look? Is it gonna look like anything at all? Wait, here it is. It has escaped my view. So, and yeah, something starts happening. So there is also temperature, and it even illuminates the spheres. But I'm still gonna add a light. Let me just, okay, let me run this. Does it work? Yeah. I'm just gonna turn off the temperature for now. So then I'm gonna add an Arnold light like this, I think. Oh, I've also enabled snapping because I was typing density with the S, and I'm gonna scale this a lot. Okay, is that good enough? Maybe I would also pick it in the Inferno display so that the light comes from the same direction. Illumination, I'm going to use a specified node because the Arnold lights are not recognized as scene lights, if I remember correctly. So use specified node, this. All right, and gonna minimize this. Oh, it keeps rendering. Yeah, so very interesting way how it refines here. It seems to use the level of detail of the cache at the beginning. So yeah, now we have density. Where is the material? Okay. Before I enable the emission, let me just show you how to also import the color. So I can change the scatter color from here. That's the diffuse color of the smoke. So we can make it a different color, or here I can pick a texture. So I'm gonna pick a volume sample, one of those two Arnold textures. Those are useful for reading data from the actual VDB. So in this case, I want volume sample RGB. You need to know the kind of channel, whether it's a cover channel for which you would have to use the float, or whether it's a vector channel in order to read the RGB. So I'm going to use the RGB for this one. I'm going to type cover here. Let me just double check. So the way that I named the grids in the Export Inferno was, yeah, color, density, temperature. These are the default names. So right here, I'm going to type cover. And it gets colorful immediately. Right, so this works. Excuse me. So, there is one interesting thing here. I think that's not sure whether this is clipping the just the bounding box that I drew at the beginning, but if it starts clipping like this, what I found useful was to increase the padding here. I don't know whether that's the orthodox way to do it, but yeah, you guys who have more experience with Arnold, please let me know if I'm doing something wrong. But also, while I'm here, I'm gonna just show you one more thing. We also import the velocity right here. So the velocity is needed when you want to have motion blur. If you are pretty sure that you're not gonna use motion blur, you can save a lot of space in the VDB files and in the RAM cache by just turning off the velocity. If you're not gonna render motion blur, if you're not gonna retime the simulation, then you're not gonna need the velocity, so you can turn it off. How to enable motion blur? Yeah, so I'm gonna disrespect the camera settings, turn off the shutter behavior, motion blur, where are you? Enable the deform keys, stop it, start again. I'm gonna increase the velocity scale right here to 10. And yeah, something starts happening. So yeah, that's the motion blur showing up in the render. So I think that by default it's in the Zenith VDBs are in the correct scale. So very little adjustment is needed here. The Zenith velocity is in voxels per second. So if you're using a different voxel size, or if you're using a different time scale, you can calculate this and then adjust the velocity scale. So what if I go crazy with this? Okay, yeah, so it's working. Yeah, and yeah, that's a good thing to just increase the velocity scale from the container. Right now, just gonna restcp those. Yeah. I hope that this managed to turn the motion blur off. Or did it? Hold on. Let me go back and try turning off the deform keys. Respectfully respect the settings. Okay, here it is. Alright, so that's it with the motion blur. And then where's my tyFlow window? Here it is. So in tyFlow, we have the ability to remap the temperature to a different color and the temperature to a different opacity of the flames. So let's enable the emission now and see what's going on there. The standard volume again. So you can control the density from here. You can make it more transparent or make it completely disappear. Should it be? Come on, am I? All right, I thought that my keyboard was broken for a second. Also, yeah, here are the different scattering options. I'm not gonna go over those. These are Arnold specific settings. So I'm just gonna show you how to quickly load that thing, and then you can go on with the shader and adjust it any way you like. So the general method that I use for equalizing the settings is the same that I showed in the video of exporting VDBs to VRay, where I just first turn off the emission, I turn off the fire, I just leave the smoke, and first equalize the alpha. When the alpha is equalized, then I equalize also the color and the shading and the shadows over the smoke, and then I turn off the smoke and equalize the fire. Again, the opacity and the colors of the fire, And when I do those two things, then I enable the smoke and the fire simultaneously, and if everything went well, it should look pretty close to the viewport result right here, or ideally it should look exactly the same. Since the renderers have more stuff like ray trace scattering, and the fires can cast illumination over the smoke, and support for multiple lights, so it likely won't look exactly the same. Also, since the renderers don't yet have support for Zenith specific things like the explosion shader stuff right here, chances are that, yeah, if you use those options, it's not gonna be able to look exactly the same until we get official support from the different renderers. Those things right here, they're included in the API, so the renderers would be able to read from them and display stuff correctly. But until then, exporting to VDBs is the way to go. So let me enable the emission. I'm gonna use channel. The channel is gonna be, it says heat. Let me use temperature. Here it is. Something is happening, so by default it's white. Can I make it green? Yeah. But can I change it? Okay, so we have lumicity, thermodynamic. Let me make it a bit more orange, maybe. Something like this. Yeah, increase the emission multiplier. So something that I found was that, let me just zero the density. Now everything is going to disappear because I'm in the thermodynamic mode. But if I use just none like this, then I can adjust the emission on its own. So this makes me think that when I'm in the emission scaling none mode, this is kind of equal to the fully visible rendering mode of Phoenix and the VRayVolumeGrid. And if I use opacity, it's gonna this is gonna be an analog to the use smoke opacity mode of the VRayVolumeGrid, where you cannot have any fire in voxels that don't have any density. While here, I can have fire even in voxels that don't have any density, but if I check the alpha channel, there is no alpha. So it just writes color without any opacity. So this looks very much like the fully visible mode of the VRayVolumeGrid. But since what we have in Zenith is actually pretty close to the use own opacity mode of V-Ray and the VRayVolumeGrid and Phoenix, which means that just the fire has its own color and it has its own opacity, just like the smoke, with the only difference that the fire doesn't cast shadows because it's fire. Then I'm not sure how to replicate this in Arnold. So I think that I can only change the intensity of the fire, but not sure if there is a way to actually change both the fire opacity and the fire intensity. But in order to map the color here to the Arnold shader, I'm gonna do something similar to this. So I'm gonna need one of those volume sampling textures again. But in order to, yeah, let me pick. So in this case, I'm gonna read the temperature. So what these curves do is that they remap the temperature to some color. So first I'm gonna read the temperature from the grid. I'm gonna use sample float this time, not sample RGB, because the temperature is just a single float. I'm gonna use temperature like this, and something starts happening, but it's monochrome, so I need to actually also use, what was it? User data, volume. Let me just find it. It was a ramp, an Arnold ramp. Ramp RGB. Yeah. So I need a ramp that takes a single float, like a single number, and then converts this to an RGB color. So Here, in order for it to work, because I can use this ramp without reading any data from the grid. So by default, you can create just a regular 3D mapping with it. You can do 3D linear. Just let me actually dial in a couple of colors. So what can I do? Something like this. Well, I've used too much green for this setup, so let me use like bright blue and what, yellow. Right, so yeah, I can use it without reading any of the data from the volume grid, and it can map like this. But in this case, I just want to set the mapping to custom. Implicit UV is off, and this is gonna map the colder temperature to bright blue and the higher temperature to yellow, like this. So I can regulate this from here. Now, since I exported to VDB in the default units, I think that right here I don't have to do much changes. But for example, if you have data that's in kelvins, here you're gonna have to increase this to, for example, like 1000. But in this case, if I do that, just the entire range is gonna be blue. So I'm gonna, whoa, let's not go too far. Let's make it 0.5, yeah. So now just changing this stretches the data that maps onto this curve. So for example, here in the Inferno display, I have minimum 0.25, maximum 6. Let me actually even just, I'm not going to equalize the whole thing, but I'm going to show you this because it's important. So let me use some kind of, okay, not going to use any other preset, just gonna delete these markers one by one. Unfortunately, there I did not find any easy way to just copy this curve onto the Arnold curve. But yeah, so here I'm gonna use like a similar color to this and a bit yellowish green, like that. And something starts happening here, and I'm also gonna just disable the fire, like this. Also, now it starts from 0.25, so we're gonna set it to 0, and it's gonna set the maximum to 1. Also decrease the intensity to 1, like this. So at this point, this should look like the thing that we have in Arnold. I'm just gonna double check if I have any multipliers anywhere else. Oh yeah, so this is also important. Yeah, so just gonna set this to, yeah, maybe keep it at 1, or keep both at 1, like this. Yeah, so in this case you gotta eyeball it a little. Here in the emission, oh, did I forget this? And yeah, I also have this multiplier set quite randomly. And yeah, that's these are the settings that you have to use to adjust this. So I can bring the smoke back now, like this, and bring the Arnold smoke back again, like 0.5 or something. Yeah. And yeah, basically that's it. That's the way to import the data into Arnold, and from here now it's up to the way that you do the shading. That's the way to import the temperature and remap it to different colors. And also right here you can plug a volume sample float again from the temperature or from any other channel, and remap it using a ramp float in this case, in order to modulate the emission like this curve right here. Alright, so thanks guys for watching, and see you in the next video. Bye!